from the graph. Now let's do it with these equations. Does order matter when we are doing compositions? Yes, there is a difference in the order. So, F composed with G. This means F of G of X. So you start on the inside. G is X minus 3. We are putting that into F. So F is X minus 3 squared. How do you square that? So we get X squared minus 6X plus 9. If I ask for G composed with F, that means G of F of X. So F, the inside, is X squared. If you plug that into G, you replace your X, so you just get X squared minus 3. Let's do, we did a composition from graph, we've done it from the equations. We might also have tables that we have to use. So if I look at this one, F of G of 1. So starting on the inside, G of 1. So when X is 1, G is 6. So then we need F of 6. So when X is 6, F is 5. B, G composed with F. So when X is 1, F is 3. G of 3, when X is 3, G is 2. C, F composed with F. So when X is 1, F is 3. So now when X is 3, F is 4. So we can do the same function repeatedly. You guys try D, E, and F. G is 6, so then we have G of 6, which is 3. E, when X is 3, F is 4, so G of 4 is 1. And F, G of 6 is 3, F of 3 is 4. Do you guys get those? Any questions about these compositions? Let's try a couple more from the equations, because that's how we will encounter them most often, plugging things into our equations. So if I asked for G of F of X here, F is 3x minus 1. If I plug that into G, what's going to happen? It has to go in for both of those x's. So now what? Yeah. Before you distribute that -2, you have to FOIL the 3x minus 1. So if we have 2 of those in FOIL, we get 9x squared minus 6x plus 1. 8x squared plus 12x minus 2 minus 12x plus 4 plus 5. And then just combining like terms. Positive and negative 12x cancel. Negative 2 plus 4 plus 5 is positive 7. We get negative 18x squared plus 7. So just make sure if you have multiple x's, all of them are getting replaced by what you are plugging into your function. If we look at b, so g of x is the square root of x plus 6. If I plug that into f, we get the square root of x plus 6 squared plus 4. What happens when you square a square root? So x plus 6 plus 4, x plus 10. Okay, you're not solving for x here. We are just simplifying this expression. So it turns into an x plus 10. Let's talk about domains of these things. If you remember from last year, you can't only look at the final answer for your domain. If I looked right here, what's the domain of x plus 10? What can x be? Negative thing, positive thing. You could plug absolutely anything in. Okay, so what if I asked you to find f of g of negative 10? So if you put that in, if I plugged it in right here, I get 0, right? But if I actually worked it out, g of negative 10, yeah, I get the square root of negative 4. That's 2i. And I'm getting an imaginary on this. So you can't only look at the final answer. When we did domains on these, I told you have to look at the original inside and the final answer together. On this inside, we have a square root. We know if it's an even radical, your index has to be positive, greater than or equal to 0, so x is greater than or equal to negative 6. Here, it could be anything. So my overall domain, you put the two together. We already know it's greater than or equal to negative 6. This one could be anything. So overall, my domain is negative 6 to infinity. So domain is not just from the final answer. We had to look at the inside as well there. So let's try another one of those. So here's two functions. We are going to find both the compositions and our domains. So if it's f composed with f, f of the square root of x, and if I put that back into f, square root of the square root of x. What's another way to write the square root of the square root? The fourth root, yeah. You just multiply those indexes if you have multiple. So my domain, if I look right here, it's under a radical, so x has to be greater than or equal to 0. If I look right here, it's still under the radical, so greater than or equal to 0. So my overall domain is just 0 to infinity. If we did g composed with f, that's g of the square root of x. So if I plug that into function f, or function g, excuse me, we get the square root of 2 minus the square root of x. That's my composition. I can't turn this one into a fourth root because the 2 isn't under my radical. If I'm doing the domain, this inside one, we know it's a square root, so x is greater than or equal to 0. If I'm right here, this whole thing has to be greater than or equal to 0, right? So how would I go about solving that? Okay. So that means the square root of x is less than or equal to 2. So then what? Okay, so if you square, so we have to be bigger than 0 but smaller than 4. If I put those together. So bigger than 0, smaller than 4. So my overall domain would be every number between 0 and 4. Any questions on this? We saw on the graphs we aren't limited to only 2 functions. We can do compositions with multiple. So let's try one of those. So if we said f composed with g composed with h. F of g of h. So you start on the inside. H is x plus 3. I am putting that into function g. So if I plug that in, we get x plus 3 to the 10th. And then what do we do? So both of these x's in f get replaced with x plus 3 to the 10th. I don't know about you, but I don't really want to multiply that out 10 times. Yeah, it might take a little bit. So we'll just leave it as x plus 3 to the 10th. Any questions? Last thing. If I give you the answer to a composition, can you work backwards and figure out what the original functions might have been? Okay, on these, there's sometimes more than one correct answer. So there's not only one possibility. We're just trying to find one of them. So what this says is when I do f composed with g, I got 4 over 3x minus 4 for my answer. We need to know what was g of x and f of x to start with. So think about the composition. You always start on the inside. That's my g. If I come over here, if you were to plug a number in for x, where would you start? The bottom. Yeah, there's other, I mean, you could just say that multiplying by 3, but more than one right answer. So I could say g is 3x minus 4. Now when you do a composition, you are replacing x. So if I'm undoing it, think of it as if I took this whole thing back out and just put an x in its spot, what are we left with? 4 over x. And then you can certainly check this. If I do f composed with g, do I get my original? This is one possible answer. There are others. You could have said like g of x is 3x, which means f would be 4 over x minus 4. That's another possibility on this one. So multiple correct answers. Why don't you guys try B? So G is the inside. Okay, the easiest option is to make your inside just what's in the absolute value. So 7 minus 3x. If you did that, think about undoing the composition. You take that out and put an x in its spot. So you get negative 2 absolute value of x. Did anyone do something different? Okay. Last one. So this one we have 3 functions, f of g of h of x. When you see cosine squared, remember from trig, that means you have this entire expression squared. So we need to think about all 3 here. H is the very inside. If I plug in a number for x, what is the first thing I'm going to do? X plus 9. So H is my x plus 9. Right, so if we're undoing that, we are replacing that x plus 9 with just an x. So think of it as cosine of x squared currently. So G is the next step. What's the next thing you're going to do? Cosine of x. All right, undoing one more time because we have a third function. If I take that out and replace it with an x, we are left with x squared. So those would be my functions. Any questions? That is where I am stopping today. I do have those, not really a quiz, but kind of a quiz that I'm going to hand back here in a second. You guys had the handout from yesterday. So remember, we're not quite done with it. Tomorrow we're going to do the word problems. And then you'll have the rest of the time to finish it up. So that handout is due on Monday. So you've got time to work right now.